couple minutes late. All right. Welcome to lab. We're gonna do lab in Linux today. So hopefully you have your virtual machine up and ready. Okay, so if you have any questions, let me know, okay? All right, so let me open this up. And so you can check out the lab. I'm gonna put my glasses on too. Now start sharing screen. So we don't have too much to do today, just a few programs. We are gonna use Cython. Sorry, my mouse is acting up on this USD. Okay. So here's our lab. Let's zoom in real quick. Okay. So in this week, we're going to use our Ubuntu virtual machine that you had created or downloaded. Now, if you're using Mac OS or Windows, another way that you can do this is in the VS Code, but I recommend using Linux. It reduces the amount of things that you have to run and things like that. So I'm going to demo this lab using VirtualBox and our Ubuntu virtual machine. So I re-uploaded the document as we changed the password on the virtual machine. So if you have your virtual machine ready, you can log into it. So let me log in right here. And let me go ahead and clear. So you are going to click on the All Apps, which is these little dots right here. And then you're going to open up your terminal. Okay, so look for the terminal. You can also search for it. So in terminal, what we'll do is we have to start first by installing Cython. So we need to do this as a super user. And I would recommend, hold on, let me get my caption. Sorry, 1 second. Okay. So we are going to use the sudo command for the super user do, and we're going to do a pip3 install Cython. The reason why we're doing sudo is if you don't use sudo and you just use pip3 like the old document, it actually only install for the user. So you want it to tie to your site packages for all user. In the case that if you need to log on as other user, you should be able to have it. So once we execute this, it's going to ask you for your password. So CIS30E. And once it authenticates you, it's going to install. It's going to ask you if you want to install. So you just press yes. And then as for me, it's already been satisfied as I installed it to test your lab. Okay. So once we install the Cython package, we need to install the compiler. So the build essential basically for Linux is going to be your C compiler. And this is like equivalent to what you would download the C++ development package in Visual Studio or in addition to Visual Studio. So what we want to do is we want to download and install that. So you would do a sudo apt-get install build essentials. Oh, I had a typo here. Okay. So once you have it installed, it would take a few minutes for it to go, right? It might confirm for you to say yes to install. So you want to press Y. And then what we want to do is we want to set up environment variable path. So that way it's always going to link to your home path to be able to execute and build your program. So you would do an export and make sure that it is case sensitive. So we want to make sure that it's typed the same. And this is going to be to the bin of your home path. And then we want to put in, this is going to be our system path. Now, if you get an error, so just check your typo, check what your syntax, if you type it correctly. You shouldn't get any, if it took it, it won't show anything after that. Okay. Now, in the past, we've used Nano before. So if you haven't used Nano, it's going to tell you to install Nano and you just install it. But you can just, most system that is Linux based, you should be able to access Nano. So Nano is your text editor. Now, what we can do is we can create a file with the name first, or so if you do nano hello.pyx, it will just make a blank file with that name. Or if you just call nano type, and then when you save it, you just make sure you give it a name. Okay, so I already have a file called hello.pyx. This is going to allow us to write the Cython code. We want to just output, you know, the text hello CIS30E. So once you have your file open, and you can do nano or nano hello.pyx like this, and it's going to open up a blank file either way. So if you just do nano, you have to give it a name when you save. But if you type in nano and the file name, it's going to let you create that file. Now, I want to put this here and show you that you don't have to use the magic command when you do this, okay? The magic command is only when you use IPython, and IPython is integrated in your Jupyter notebook or your Sage or your Colab notebook. So you simply just write one line, print hello CIS30E. Now, if you put the magic command, it should still work, but you are not required to do the magic command like what you've seen in the assignment for this week. So I have print hello CIS30E. And then once I have that, I'm going to go ahead and click Control X together, and then press yes, and then save my file as that name. Okay, so it's going to ask me, do I want to save? I'm going to go yes, and then make sure that this is when we type in our file name if you didn't give it a name earlier. So we're going to go ahead and press enter to keep that name. So once you have your file, and now this file is going to be put in your home directory, which is like equivalent to like your documents in Windows. So, and your home directory is where, you know, the default for this particular user account. So once we have our hello.pyx file, right, in order to build this program, like what your book and the notes talk about, you have to run a setup file. So what it's going to do is going to compile the Pyrex file or the PYX file using the setup Python file. And in our Python file, we simply just set up our import statement. We are going to use these modules we already installed Cython, and setup comes with your Python package. So we are going to do 2 import statement. And then you want to use the setup function to call on the external module. So this is going to be your external module. And we're going to, for the external module, we're going to use the Cython nice, and that's going to make your build essential package activate. So at that time, we're going to use Cython nice from Cython, and then it's going to use the compiler to build your Pyrex file. Now, when you compile your file, it's actually faster, and this lab is going to show you that, right? It's going to show you how fast it's going to run that particular application compared to if we're using the Python file. So we are going to go ahead and do nano setup.py is a Python file. Okay, just py, not pyx for the setup. And so let me move this over a little bit. So I have my setup file set up or written. So you just have 3 lines, right? Now your setup file should always contain whatever file, that Pyrex file that you're trying to build. Okay, so the pyx file. So since I'm trying to build my hello.pyx, that's what I'm going to pass in the Cython nice parameter. And that's important. So as you make the future setup file, you just got to make sure that this is going to be for the new Pyrex file that you're trying to build. Okay, so it's going to take your Python code and convert it to for C compiler to build. And that's why we're using the setup file like this. Okay, so after we have this, what we will do is we're going to save it. So Control X, and then yes, and then enter. Okay, as I didn't modify much, I just hit Control X and it's going to take me back here. But you have to confirm that you want to save it to buffer, and the name is setup.py. Any question? Okay, so the third step after we have the setup file, right, is to be able to build it now. Okay, so there are 2 components for this when you're using Cython. First, you write your Pyrex or your pyx file. Second, you write your setup file. Third, you are going to use Python command to build the file, right? Writing the setup file doesn't necessarily mean that it's built. So we have to do step 9, which is the third element to this. So we are going to do a Python 3, right? And we are going to use the setup file that we created, and we're going to tell it to do the build extension package and space -- in place. Okay, now if it's throwing an error, there are 2 things that you need to check. It will, in the error, it will tell you exactly where the error is. So if it is your Pyrex file, you need to go and nano back into it and edit it. If it is your setup file that have error, could be syntax or whatever, something missing, what you want to do is you want to nano back into the setup file to edit it. Now, anytime that you modify these files after build, you have to rebuild. Just like how it is in Visual Studio or VS Code, right? Once the program is edited, in order to see the update, then you need to rerun or rebuild the program. So whenever you modify the files, you have to rebuild it, okay? So if it runs and it tells me these things, that it compile, right, with the GNU GCC, okay, and it tells me the version and all of that. That should be okay. If you're getting traceback error, that means that your file is either missing components or it has syntax error. So you would need to go and nano back. So to do the previous command, you just press the arrow up key, right? Like this. It will, I press it twice, so it go back 2 steps, and then the arrow down key to go forward. Okay. So you don't have to retype in terminal and command line. For most part, you just use the arrow key if you want to go back to the previous commands. So arrow up to go back, arrow down to go forward. Okay. So after we build, now we want to see the output in shell. So you are going to do Python 3 to access the Python shell, because we want to see the output here, right? And because the way we wrote the Pyrex file, it is a module or a separate file. So we want to tell Python to import in that module, which is hello. Now you don't want to use the extension here because it's simply an import statement, right? Just like how you import in regular Python code. So you just use the module name without its file extension. So you are going to go ahead and type import hello. And if it works, it's going to tell you the output there, right? So I see hello CIS30E. So at this point, I am at step 11. You can screen capture this, right? Just take a press print screen and paste it into the lab, or save it as an image. So if you paste it into one document, you don't have to upload multiple files. So as we go through, just take the screenshot and paste it into a document, and then you can upload it just one time. Now to get out of the shell, I just simply do an exit function in Python, and it's going to take me back to my command line. And that's how you can use command line directly to write your code, and then to run your code. And in this case, we're going to do the build, and we can test it with Python. Okay, so this is how you can use Python to work with Cython package, which is it needs a C compiler. And for Linux system, this is, Linux is really made to be used with programming language like Python, right? So this is why it's important that, we know how to use multiple OS and use Linux to test, because you might be using this down the line for your job. Okay, so we had finished number 12. Now in the next step, I didn't give you a code for this, but you can also refer to your notes in your assignment. We did a little bit of this where we would type and we would be able to display some variable content. So in 13, it tells you to use Cython. So we know that we need to use Cython. We need to make it a PYX or a Pyrex file. We are going to declare 2 variables. So that means that we have to use cdef when we declare, and we got to type it. So var1 and var2, and we want to assign var1 100. And var2 is twice the value of var1. So we simply take that, multiply it by 2. And we want to type this double. Okay. Then we're going to cast var2 data type to int. Now, if you know data type, when you're going from double to int, you are downcasting. So I am going from a larger size, right, as far as storage goes, to a smaller size. Now, in Python, usually a lot of the times you don't have to do the type, right? You can parse it to a certain type, but in this case, we're using Cython. So because Cython is using C, it is strongly typed. So we got to start the type at the beginning, and then we're going to cast it. Then after that, we are going to make a setup file. So you can simply edit your previous one and resave it, right? Just make sure that you put in the new file name inside the setup file content, and then you're going to build. So because for the demonstration purposes, I actually wrote different setup file. I saved it as a different file so I can show you. Okay, so I'm going to go ahead and nano into my code. So I call this var1.pyx. You can name it anything you want. Okay. So again, we don't need the magic command, so we can remove this because we're not running it on IPython. We're just gonna use the C compiler. So I want to define, and I got a little lazy with this one, so I just want to define my variable. So I just made them both double. Okay. And if you want to make var1 int, that's fine. Just separate it because in the assignment, it actually tells you that var2 is double. So since it didn't say anything about var1, I just made both of them double. So you would start with cdef, right? Double var1, comma var2. So that means that var2 is also going to have the double type as we're using a separator there. Then we initialize var1 as 100. So when you assign this value, you can also assign it directly into that one line, right? So I just wanted to keep it a little bit more thorough. So I initialize var1 at 100. Then for var2, because it's 2 times var1, it's double. So I'm going to take 2 and multiply it with var1. Now, there are several ways to do this. If you read Cython documentation, they tell you to use the package name. And then because you're using Cython, and you can do an int, right? Another way that you can also do this, let me move my cursor down using my arrow right here, right, is you can type it like this, or you can reassign var2 is going to be int, right, var2. So you can force type or downcast it using this way. I think in the IPython, you have to say type in the arrows and then int and that. So you can also do it that way. Okay, so there are several ways that you can do this. So this is going to be the same as the next line. And I wanted to print out the values so I can see, right? Otherwise, I won't be able to verify. Okay. Now, if you are familiar with C++, what you know is when you downcast, when you're going from a larger size to a smaller size, you can't just simply cast it. You have to truncate it. So in C++ or C, it actually you have to use trunc to actually downcast it. Otherwise, because double is larger than int, it's going to automatically cast it as double because it's going to take the larger container. So don't be surprised if you're looking at it and it's still showing like the double, because we didn't use the truncated in this one. So it doesn't drop the decimal point. Okay, so I just want to let you know that, so when you see the result, you're not going to be surprised. Okay, because there's certain requirement in C that we have to be aware of when we're using C compiler. So after I have my code, I'm just going to press Control X, and it's going to ask me, do I want to save? So yes, and make sure that I have the proper name. So I have var1.pyx, and I'm going to press enter. Then the next step is to make my setup file, right? This is requirement E for number 13. So we are going to go ahead and we are going to take nano. And what I did was I call it setup var1.py. So I can demo without having to edit my file right away, right? So it is exactly like the other setup file. So all you have to do is nano into your setup.py, and you're just going to modify the third line. Make sure that this right here reflects your file name that you just wrote. So I just created the var1.pyx for number 13. I just got to make sure that that file name goes there in the parameter. Okay, so you just have to modify the setup file and then you save. So Control X, yes, right, enter, and it will take you back to the terminal. Then after we have the setup file created, we're just gonna make sure that we build, right? At this point, we're gonna compile. So that means that you are gonna repeat this step, number 9, okay? So repeat number 9. So I'm just gonna up arrow key so I don't have to retype. Now earlier I had a different setup file, so I just want to make sure that I change this. Okay. But if you're using the same setup file, you just up arrow key and press enter. Okay. So let me see. It says it's raising an error for line 4, Cython 9 for I'm having an error here, so let me check. Cython 9. Oh, I see. Let me go back to my, let me double check. It's not. So it didn't like. I wonder if I do this. Yeah, because I'm using this right here. I didn't like that. Okay, so let's see. Okay, that fixed it. So you saw what I did here. I'm going to come back to that for you to see. Let's arrow key it up. So if you use the Cython.int, of course, it's going to look for this. Okay. So because if you're casting it like this, it's going to look for the module. So if you use it this way, right, what we want to do is we want to make sure that we would import in. So I just do import Cython as Cython. And then since I'm using lowercase Cython here, I just say Cython.int. Okay. And that took care of the error. So when I build it, okay, I just got to run the Python 3, my setup file, build the extension package in place, and it should build fine, right? It already built, so it's just running the extension, and then now it's fine now. Okay. If you're getting traceback like what I had before, right, it's just saying compile error. right? It's looking for the package. Okay, so now after we built our program, we are going to do Python 3. Okay, and then you're going to do an import, and my file name is var1. Okay, so on the Python side, you notice that it didn't like this right here. So what I have to do again is I'm going to do Cython, Cython, and then import var1. Let's see how it does it. Yeah, it didn't like that. So let's fix it. So I'm going to go ahead and just comment it out or delete it. I think in the function, it probably works better. And then as I edit that, oh, sorry, it's going too fast. Okay, I did save it. So we're going to save it after we edit. And let me rebuild it. Okay, so let's check. There we go. So I think, as you can see, it's still kept, and this is a Python thing, right? It still kept my double type here. It didn't drop it because it didn't truncate it, because once I cast it to, or once I declared with the higher container in memory, it kept it like that instead of downcast it. So in order to downcast it properly, we will probably have to truncate it using the C compiler. Okay, so now I'm going to take you back just in case you get confused. So for the casting, we simply can just type it like this, or you can also use type and then int and then var2. And I think this is the example that the book shows. Okay. So we just reassigned it. Okay. Let me take that back up. So just going to bother me if it's in the second line. You can run it in the second line, but I don't really need that anymore though, but okay. So this is not necessary. You can simply just write it like this, because I tested this earlier without this part. Let's get rid of it. Okay. So your code should have a CDEF, right, for defining your variable for C or for Cython, and then your variable name, and then initialize your variable and do the operation for 2 times. Okay, then we're going to cast it, then we're going to print it. So save it and then build it. Okay, and then run it, and then import it, and there you go. Now, when the difference too, when you look at this, is even when it takes it to Python, right? It's going to include, it's going to put it into the tuple that you see there. So it's going to show, and then it didn't downcast it for me. So it's going to show 100.0 and 200.0. Okay, so at this point, once you have all of that ready, you are going to screenshot. Then we can get out of shell. So exit. Oops. And that would take care of our 13. Any question? Okay, so for 14, we're gonna use NumPy and Cython. And when you look at the code here, it is pure Python. Okay. And so we want to run this to calculate the sum of all the elements. But we can build this into a Pyrex file for Cython. So your Cython code, compile it, and then run it in Python. Okay. So compile it and then run it in the interpreter. So what I'm going to do is, hold on, let me list my file real quick just to recall. Okay, I did have it as sum. Now, when you do ls command, as you can see what I did here, I'm looking at my home directory and all the files that I created. So when you built your file, like what we just did with bar1, with my previous exercise, you see how it created a .c file there. So once it built from the Pyrex file with our setup tool, then we are going to see the .c file. Okay. And so, and then it's going to tell you this right here, that it is a Cython. Okay. And the same thing with the others. So the hello one, see? Okay. So you can always use your ls command to look at your files and making sure that you have the right file. Okay, so let me clear. Let's come back. Okay, so now we're gonna make a new file, and I chose to call this file sum.pyx. Okay, so when you start writing your file, you can say nano and then your file name and just give it the file extension pyx. And I pre-wrote this, so it saved me some time. So in this particular program, we're going to time it, right? We are going to run the time module. So we are going to use the NumPy library, the time library. We're going to initialize the total because we are doing a running sum program. We're going to have an array. And so this array is going to be to the range of 100. And with that, what we're going to do is we're going to time every single subtask. And this is how you can test your program, right? Remember we talked about big O notation and your runtime in the second one? Yeah, when we're profiling. So what we can do is we can create a task, right? Time. So we're going to measure each of the tasks that's going to run. Okay. So here, what I have is I have T1, and T1, I'm going to use the time module to time my task, because at this point, we are going to implement linear. So linear execution in the loop. So we're going to have it loop through our array, and it's going to take each of the element as it loops. It's going to add that up, right? And so we would have the complete total at the end. For my T2, right, I wanted to, so this is the start, right? And you wanted to time it when it finished. So to really find the time is you're going to take the time that to finish minus the time that it starts. So the time that it finished, subtract the time that it starts, is going to give us the actual time for that task. Okay. And you're going to see this more often when we go through the course. by the end, you're going to see that, you're going to be very comfortable seeing this, because if you want to measure time, you just gotta, turn the clock on when it starts, stop the clock at the end, and then we would be able to subtract and look at the difference. Okay. So that allows me to keep time for that task. We want to print out the sum, right? And here for our time, because it's going to be in decimal, this is simply just to format it. Okay, so RT is going to be the actual time where we take the difference from the start, the finish and the start. So as I complete this, I'm going to go ahead and press Control X to save, and then yes and enter. And it's going to take me back to my terminal. Okay. The next step is to create our setup file. So you can go back to your previous setup file and edit it. Okay. But I actually have a separate file called setup_sum.py because I want to demo. And all we need to edit is the third line once again, right? So the Pyrex file that you just created for number 14, you would plug the name of it there with its extension. So once we have that written, we can save. Then we would build. Then we would use Python to execute that in shell. So this shows you the steps on how you can start with Cython code, right? Build it with the setup Python file, and then use Python to execute your file. Okay. So now after we have our setup file, we're going to save. Control X, yes, enter. And then we're going to run. So you would use step 9 from this lab, right? And then you just got to make sure that your setup file name is correct. So in my case, I have setup sum, but if you're using the same name, you just rerun that command. So we are calling on Python 3 to execute our setup file to build, right, our Pyrex file. And it shouldn't throw any code if you have all your syntax correct and your setup file correct. Okay. And yours might have a little longer, like what you see in my build from earlier. So once we build this, we just call on Python 3 and to access its shell, and then we're just going to import in our file name. Okay. Now, the funny thing is, if you look at the output, it's going to include everything that you use in the print. Remember that this is, you're accessing Cython. So C uses a different print command. So this is why it's showing you like all the content of what you tell it to print, even though we're trying to show it in Python. So earlier this week when we did the assignment, you saw how to use printf. You can import in the clib and be able to do the printf command. So that's another way that you can print more cleanly. C also support pretty print. So there are other functionality in print for C that you can incorporate when you're using Cython. Okay, but for the sake of the exercise, we're just going to mitigate all the extra step, right? So here, what I show is this is the actual time that it uses for the loop. Okay. So it shows my total and it shows the time. So take a screenshot when you get to this point for number 14. Any question regarding 14? Okay. Now I want to get out of the shell, so exit. All right. Now, when you write factorial program, there are many ways to approach this. You can use recursion, right? You saw recursion being used in our prior lab when we did Fibonacci. You can use a loop. So there are several approaches in this. So this is a factorial program, right? So you would initialize and then you would just increment through, and you would take the value and you would multiply it with the previous value. Okay, and this is how you would write it with a loop. So this is a linear approach. Okay, but we can definitely rewrite this, make an algorithm that's a better algorithm. So what I want to do is I want to do two things. I want to see how it is as a Python file and how it is as a Cython file and which one is faster. Okay. So the first part of 15A is going to be pure Python, right? If you read their documentation, they have two toggle. You can look at how the code is with pure Python compared to Cython, right? We wanted to see if Cython is faster. So what we're going to do is we're going to go ahead and nano into a new file called python test.py. And this simply is a Python file. So we would use the simple Python syntax, right? I have a function called test. And for that function, I'm going to pass x. Then I have y initialized at 1. I have a for loop or for range, right? And I would then increment starting at 1, and I'm just going to take that and increment it down the line. So as I go, I'm going to take y and I'm going to multiply it by the index value. And for the function, I'm going to return y. Okay. Now, if you want, you can have it print out the values and so on. But we're just simply implementing the function and see how fast it goes. Okay. So just a few lines. Once you have your Python file written, we're just going to save. So Control X, yes, enter. The next step for B, we're going to make a Cython file. So we're going to go nano, right? Cython test.pyx. As it is a Cython file, it's a Pyrex file, so we're going to do pyx. Okay. And here we are. So unlike the other file, we're going to have to do this, the definition. So when you're using cp def, that's for a function. So we would say cp def. Now this function type is going to be int, and the function name is test. As we're using x as a variable, we're going to make sure that we pass int x. Then inside that we have local variable is y, right? We got to initialize y. And so you would say cdef, int y is 1. And we got to also declare I because we're using that in our loop. So we would say cdef int I. And so that, right, allows us to declare the variable for that function. Those are the local variables. So once we have the variable declared, then we are going to implement the for loop. So we would say for I in range, just like before, we would have 1 and then x plus 1. And then we would take I times the index as it goes. And we will return y. So once we have the Cython code, we are going to go ahead and save it. So Control X, yes, enter. Then we're going to do the setup file. So you can go back to your setup file and modify, or in my case, I have a file for it. So for my setup, I would change up my file here. So make sure that whatever that you're trying to build, right? The file that you just wrote, gotta make sure the name is there in the parameter. So we would have Cython test.pyx. You can edit your setup file and save it. So Control X and then yes, enter. Then after that, what we're going to do is we are going to run. So let me go back to that and I'm going to edit my command here. And so for you, simply just do the same command for the setup.py, okay? So if it built successfully, if we don't have any errors in our program, right, it should tell you that it's built. I already built it, so it just simply rerun the build, okay? So once you built the Cython file, now you are going to write the next code, okay? Because we got to compare. So in this program, we're going to call it testcode.py. And we're going to import in 2 of our modules that we created. Remember, the first step is the Python test. The second step is the Cython test. So we are going to import in those files. We're also going to use time to measure. And then what we're going to do is we're going to initialize number as 100. And we're going to do a start time. Then we're going to run the test for the Python file. We're going to end the time. So this is where we turn the clock on, run it, turn the clock off. Then we're going to take the difference to look at how long it takes for the Python file to run. Then we're going to turn the clock on, run the Cython test, turn the clock off, subtract to get the difference for the time, and print. Okay. Then we're going to do the division operation because we want to take the Python file divided by the Cython file to look at the speed up. Okay. So that's going to allow us to compare the Python with Cython. Okay. So now I'm going to nano into my test code.py. So as shown in the exercise, we're just going to input in our code. We have import the modules in time, start the clock, test the Python file, print it, start the clock, test the Cython file, get the time, print it, then there's more, right, on the next part. So we're going to do the division to look at the speed up. Okay. So after I have this, I simply save. So Control X, yes, enter. Now to run for step 17, you simply call on Python 3 because it's a Python file, testcode.py. Okay. So by this point, we should know how to run it. So Python 3 testcode.py. Okay. So we see that for the Python time, it's this right here. And this varies from one system to the next, just like what we've seen before in profiling, right? And then for the Cython, it's this right here. For the speed up, I would see that it is 0.83. Okay. So that's how you can set up for the comparison between two programs. And you can do that for all of them. You can write a Python version and you can write a Cython version too. Not too much of a difference, right? Like we just need to define and add the type specific ways in Cython. Okay, so we can see that it is 83% roughly for my system, right? Now, you know, there are other factors that we should consider, okay? You know, the number of cores, and since this is just a synchronous Python file that we're testing, you know, we're not considering other hardware factors as well, right? Like my processor type, and all of that. But in general, what you can see is if we're testing it in this environment, we would want to run more tests as we learn in profile. Okay, so screenshot that. And this is a fairly short lab, so it gives you time to play around with it a little more. Right? If you like Cython, you can just take all your Python program, write the Cython version, and run it and see. Okay, and now you know how to be able to write program in Python to test other programs in Python and Cython, okay, through this lab. So this lab gives you just short example, but you can take this and you can apply it in development environment, you know, for testing applications, you know, when you're writing. So if you want to see which one is faster, especially on the lengthy, more complex, right? We also learn how to profile, so you can also profile your program. But in this particular chapter, we touch on how to use C compiler with Python. And you would see more of this when you're using C-based libraries. For those of you who are interested in doing like IOs, especially with like hardware. If you learn Raspberry Pi, where you would work more with like the IO libraries for LEDs and things like that. A lot of the times those type of libraries are written in C, but converted for Python use. So down the line, you're going to see that we are going to be exposed more to C-based modules or library. But, you know, as far as C Python or Cython, this is what you normally see. And, you know, they are continuing to support this and improve the library itself or the package itself. So down the line, you're going to see the more capability of how you can implement Python with C. So I just got notification this morning. I read an article how Python has a flaw. So there is a flaw in Python on the security side, which creates a lot of issues for 350,000 applications that implemented this particular piece. So, and the flaw is actually found by a 15-year-old. So, you know, when you develop using programming language, you just got to make sure that you keep in mind that there's always the security element, and your application is as good as all the libraries and modules and the package that you use along with your programming language package, right? If your programming language package and that has a lot of risk, your application will likely be prone to risk. So in the security assessment area, when you're looking at like web application or application in general, we normally come back to the type of tools and things that you use in your application and be able to you know, see how that application can be prone to risk, what's the risk level. And then we would look at the content and how the design would be implemented, right? Either through UI or, you know, other areas that would relate it to frameworks and so on. So, you know, as you expand more into Python and also other areas in development, you're going to learn additional elements, right? And I hope that I can give you some additional knowledge and perspective in how you can use Python for your career, your education. Okay. Any questions regarding the lab, as it is simple and short? Okay. So if you don't have any questions, I do want to bring your attention to your announcement before I end my session. Let me come back to my dashboard here. I did post a couple of things for your course announcement. I know that some of you are in cybersecurity, some of you are in just computer science, but I want to share to everybody. So in case you're interested, for the student that are competing in National Cyber League, they are able to get different type of scholarships. So I posted, there was one that for CrowdStrike, I think 3 or 4 of my students actually took advantage of this past. So, but if you are competing in National Cyber League, you can also go for a $5,000 scholarship through ISACA. Right now, they're trying to boost a lot of the cybersecurity, technical workers area for employment, and a lot of the times you see these competitions is contributed by many tech companies. So ISACA is pretty big in the industry as far as for IT audit. There is an IT fellowship opportunity with US State, and it covers the 2 years for your undergrad, which is your bachelor degree. So if you want to help lift some of the tuition, now make sure that you visit the website and read the commitment in that. It is a 5-year contract after the fellowship, so they do give you jobs. And I see this every semester. So if you want to do this, you know, it's not, even if you go for computer science, if you want to work for US State Department, you can check this out. There is also Microsoft Cybersecurity Scholarship and other things. So I think I have an internship information that's in the works, so I will share that with you once I have the information. So you can check out the announcement if you're interested in these things. Okay. All right. So any questions? Okay, so the lab and the assignments are due on Sunday. If you have any problem or anything, just make sure that you let me know. Right. I can help you via email, or if you need to jump on Zoom to troubleshoot some of the things, I will try to catch up with the grading for what's left, because I think I did some of the prior week. We do have an upcoming quiz. So, and for the quiz, the best way to review is to play the review game for extra credit. and also go back to your notes and your assignments in your lab. So the questions will come from your notes, assignments in the lab, okay? So the quiz is going to cover chapter 1 through 4, and it is multiple choice, and you do have 3 tries. Any question? All right, I'm going to go ahead and stop share and stop record. I'll stick around for questions.